All right, apologies for all the technical difficulties. We will, as always, we make do with like the resources that we have, and we try to have the best possible result. We are actually ready to move on to our next major topic, which is the functions topic. In terms of just administrative reminders, this Wednesday is our next macro quiz. So we've been having the micro quizzes. The macro quiz is really just more of those same type of questions in just a somewhat more constrained environment where you really just have one go at the question. It is effectively just covering what we've been covering the last 4 weeks, basically everything we've been covering since the prior macro quiz. So we started with branches, and maybe now that seems like such an obvious topic, but we started with branches, then we worked on loops, and then for the last 2 weeks, we've been looking at arrays and how arrays and loops do kind of go together. It'll be the same flavor of questions, the same general type of questions, the same length as our previous macro quiz. So, look back to the first one. If you're happy with how you did, then do the same thing again. If you'd like to get a better score, my best advice would be, still to look at the Zybook questions for the same type of questions that we would get about these same topics. As they are multiple choice questions, they tend to be more commonly, what is the result when this code is printed? Or what line needs to be added here to get this code to do this particular thing? So it's not as simple as questions about what is a while loop, or what is a for loop, or what is an array, but just meant to kind of just demonstrate understanding of those topics. So while programming experience that you're getting through the coding practices, through the Zybooks challenge questions, and through the lab, that's still very valuable. And I do think, getting that stuff done for this Wednesday's deadline for RA5, CPO5, and get towards finishing, if you haven't finished Lab 5, that is also still prep for this quiz as well, because you're just getting more experience, more comfort level with programming, and that's really all these quizzes are really meant to demonstrate. Sure. Will there be anything involved with this week with functions on the macro? No, because I'm not sure how much we're going to get to this on functions. A couple things about functions. We'll be able to cover this pretty quickly, actually, I think, with regards to, because we have been, by necessity, using functions the entire semester. So in terms of what is new, there's a couple things that I think are interesting and new, but not nearly as much as working with arrays and loops and things of that nature. So it's a much more modest topic. And the quiz is on Wednesday, so we won't have time for you to review. So up through Module 5, whatever you want to call that, Reading 5, Coding Practice 5, Lab 5 is what is fair game for Wednesday's quiz. So I'm happy to jump into functions with the caveat that technology is really fighting me today. So if stuff just doesn't work, I may just give up and kick everybody out. As it's due very soon here, are there any kind of things that you are stuck on with Lab 5 that you would like us to review together in the time we have here in class, separate from office hours, separate from lab time? Are there any of those lab questions that are still giving you any troubles, or are we generally okay and can kind of just move on, having to finish them? Yeah, sure, in the back. You'll have to speak up a little bit, sorry. The barcode one, yeah. And let me attempt to open up that project just to kind of walk you through what's necessary for that. Actually, the one that would be easier for me to open up, easy being a relative term, would be from a couple of weeks ago. We've been playing with the GD library a couple different times, and most recently in class, we opened it up and played around with it. I mean, it'd be nice if I could just open up somebody's here, but I don't want to open up someone else's code without asking them first. We were playing around with it in class, trying to do like a pink hair filter. And that was part of lecture 5. It was called something fun. Everything's fun. Well, no, this one's called image processing, and it is fun. And part of the issue is that in part 4, like the color filter part of the lab, the instructions were very explicit, saying, if you remember this is when we were playing with pink hair filters. For part 4 of the lab, the instructions were very explicit, saying, here's how you configure your replit environment to be able to use the libgd library. And then all it says for part 5 is, do that again. Do those same instructions. And I'm hearing not just from you, but from several different students that, well, we split it up that one person did part 4 and now I'm responsible for part 5. That's fine, but then you have to be in communication with each other as well. So that would be my recommendation. But I can walk through it one more, well, maybe I can. I will try to walk through it one more time, what I meant by those part 4 instructions. Because I do believe once you have that, it should compile. And there's a video from that class as well, but one thing we talked about is that there's really kind of 3 steps necessary for things to work well. See if I can get this to work, because if I can't get this to open, it's not going to work. Okay. To get, first off, that libgd.h to not lead to an error, and to get that magic compile button to work properly. Let's see here. We can do this. We are capable. Maybe. Now I have to tab over. Okay. We have to first configure the replit environment, or whatever environment you'd be using. It's not really unique to replit, but the solution is specific to replit. We may have to go back to dry erase board here today. Is to make sure you actually have to install an application that allows you to develop for that particular library. It should just be, so here / I think I could just do, no, that doesn't seem to be working. Okay, let's go back to it. And that is different for every operating system and configuration that you may have. Specifically in Replit, there's a hidden file called the nix configuration package. It's replit.nix. I'm struggling to get to it. It's here though. Let's see if I can. They might, but we're going to sort this out. We are capable. Pass it to me. There's a little, oh, I need a dongle, but no, I need a USB-C dongle. I have no straightforward USB-A/B. This is a team effort. Okay, what do you have? Okay, here we go. Well, I mean, otherwise, it's not like this is working. So whose time are we wasting here, right? So that's fine by me. Thank you, sir. All right, so from connector to connector, well, now I've run out of spots here. Although in theory, if I am connected to this, in theory, that should work. Any promising, in theory, a lot of things should work. God, this day. Okay, try the connector. Because that's also not working. The camera in here is not working. I'm just gonna go home and cry. All right, I see. Turn her off. I have one of these mice as well. Okay. Oh, should have it. The light is on. It is not green at the bottom. Does it have like a switch for like what setting, or let's see here? No, it's on. So it's on. I got the same mouse. It's got power. It's green on top. Could be. No, it's. I mean, I could always just. You may just get some enjoyment out of watching me struggle for like 50 straight minutes. Every other day this semester is like, mastery of programming, and today can just be struggling with basic technology. It's fine. The issue is I I'm not going to post this video either, by the way. This is getting deleted as soon as it's recorded. And people wonder, oh, where's that Monday, October 9th? It got lost, just, it was but if this hadn't happened 1 minute before the start of class, it wouldn't have been as much of an issue. Let's see, because it could be my computer that's not working, because it had some scary looking BIOS message. Okay, I'm not going to lose anyone's equipment here. Let's try this again. It's just set to not want to have a mouse. Okay, well, I appreciate the nice thoughts. We can do this. No. I refuse to believe this is beyond my ability. We just need to become, back in the day, we didn't have mice, right? It was just a keyboard, or even worse, interfaces. Who knows? I don't have permissions. This is part of the issue. It's not my computer. It's, ETG sets up the computer. Okay, let us try to talk about, okay, hold on. If I do that, nope, that just tabs inside the code because it steals it. 3 things you need to do, and I'll say them out loud because I will not be able to show them to you very easily. One is you have to configure Replit to install an actual package. The right term for that is like the development library for libgd. What are the binary blobs that are already kind of pre-compiled and the headers corresponding to them that lets your compiler link to those existing libraries? I mentioned when we did do this video earlier in this semester that as far as I know, it's kind of a fundamental problem with package management and building complex software. You have to know the name of what that package is going to be, but there's no obvious name for things, and you do wind up having to sort of do a Google search for what is the name of the libgd development package in the Nix operating system or the Nix package manager, and it happens just to be called GD. So you'll add a line to your replit.nix file saying, for this project, I want to have the GD library included. Then you have to potentially modify your make file. That's if you want the run button to work. If you just want to manually compile things, you still can. And it was the libgd library that does, fortunately, talk about that. Talks about it early on in the documentation for it, where one of the first things it says is, here's how you compile, basically. Here is, now that you have the library installed, and it doesn't actually say how to do it, it says you have to install it, but once you have the library installed, once you've changed that replit.nix file, in your make file, and it does look kind of like nonsense, but we talked briefly about what those individual things are implying. You tell your make file, either you type it in manually command line or you put it in your make file so it gets built this way every time. You say, I'm going to be compiling my code, my .c code that I myself am writing, whether it's called main.c or whatever you call it, and I'm also going to link in other libraries along the way. We haven't had to worry about that too much because for the most part this semester, we're just using the standard C library. And that's kind of given to you for free. You don't have to specify you want to use the standard C library, you just already get it. But to work with libgd, they recommend add these other libraries, and this is the syntax for most Unix flavors. -L, lowercase l is telling your linker, include the library that's after the -L. So include the libgd library. Include the PNG library, which just happened to already be installed. We didn't have to install it ourselves. That's to open and write PNG files. -LZ, it stands for zip library. For certain compression options, for JPEG, it uses that. JPEG for JPEG library. Free type, which is a font library. And we actually briefly played around with just deleting this part, and it worked just fine because we weren't doing anything with fonts in our usage. And then finally, -LM for the math library, which is something you'll use more frequently in other projects as well. You would then add that to your make file. And there's a couple different places you can put it, but the usual syntax is we have sort of C flags for compiler flags, saying a flag, just an option. Here's what I want to tell my compiler to do, how much it wants to do optimization, what other things to maybe include. Then there's L flags or LD flags for, here's what I'm telling the linker. Here's the binary blobs to grab together to combine with my main.c's compiled output to generate the file executable. that's where you would put that in your make file. And then finally, once you've done that, then main.c should be able to recognize those functions defined in gd.h. Replit isn't always that great with it, which is why I included that file locally. That's why it's in, we'll talk about this, when we talk about functions in more detail. You can already see the slightly different syntax there for those includes. One is using double quotes and one is using just those pair of brackets. The distinction isn't necessarily that interesting, but what it's really saying is when it's using double quotes, look locally, look relative to the current project I am in, as well as anywhere else I specify, and look for that header file there. Whereas if it's in the brackets, look in whatever system installation of header files for this particular file. Replit should be good enough such that I should be able to do this, and it should still be able to find all the various data types and function names and things like that. But sometimes it is and sometimes it isn't. So I did include that file locally. That's the third step though. That's a header file, and this is relevant to our discussion of functions starting today. That header file doesn't necessarily implement any of the functionality for the library. So there's this function called, let's find one of the ones we might use, GD image create from JPEG. Takes an open file handle that presumably corresponds to a JPEG image file, does the actual loading of stuff into array, and returns this kind of pointer object that says, okay, that's an image that you can start to manipulate using other libgd functions. There will be a description of this function inside that gd.h file. But the actual implementation of that function, we don't necessarily even have the source code for. In this case, it's all open source. We can grab the source code for that implementation. But if you have the header file that describes what that function is supposed to be, and you have the library, the binary blob that is somebody's implementation compiled to an executable format for those functions, then that is all you need. And the linker is what determines, given the name of this function, given the various places I'm looking for binary blobs, can I ultimately find that function or not? And that is when we jump into Lab 6, the actual functionality in Lab 6 probably is easier, I would say, to an assignment than Lab 5. Lab 5, it took us 2 weeks, and we had to kind of really build up some examples. I was expecting some game of life questions today, but I can't get code to run anyway, so I don't know if we can even get to it, but we'll try. In Lab 6, what you are doing is basically building your own library. So you're building your own version of that. We're going to be writing some functions. They're not meant to be too hard. Basic functionality for just some relatively straightforward things, and we always start with toy examples when we learn a new concept, right? And then we're going to package that into a library such that when you take that library and now put it in a different Replit project, you can still use all those functions even though you don't have the source code for those functions in that library. It's a little artificial because you yourself are writing all the code, so why package it up and then copy it over? But just to show that concept, that's how we typically want to encapsulate software such that here's these functions or data types or other things associated with a very particular task we're interested in, like editing images, like working with images. We have it as a separate thing, we install it. We then do not have to write all that much C code ourselves. We just have to understand the functions that are out there and link them all together at the end of the day. Very long story short. If you go to this example in Replit, the lecture 507, or probably go to your partner's lab 4 and look what he or she did for that, it's just you have to do the same exact steps again for part 5 to get the barcode example to also compile. Other lab questions or otherwise, we're good to go. Did you get Game of Life working? No? What could I show without actually programming? Well, we have it open, sort of, with no previewed file. This is the starter code for Game of Life, and for better or for worse in this one, I did try to provide more comment. You don't have to do it the way I do it, but that's just one method that I think would lead to a kind of guaranteed result. So we declare a board of a certain size. And again, game of life, meant to be a type of simulation of sort of bacterial or other, population growth in a contained environment. The idea is you start with some initial population, and based on competition for resources, the population either grows or it shrinks over time. We can do it in this two-dimensional way, and it kind of leads to some interesting kind of visual results here. In this case, what we are defining is this two-dimensional board, this grid of individual samples, and you can think of it as a petri dish if you want to. Let's call it a square petri dish of size 35 by 35. What we specifically do to begin our implementation is then to declare a border around it as well. So if m equals 35, then there's this n, which is going to be 37. For our purposes, I think it makes the code slightly easier. I mean, we'll see as you work on it. You can visualize that if m is our petri dish of a grid of size 35 by 35, then n is like a perimeter of acid around the petri dish, or just the wall, whatever you want to call it, where like no matter what, nothing is growing past that border of size 35 by 35. It's not strictly necessary, but it's a way to make some of the conditional statements we have to write a little bit easier, in my opinion, a little bit easier to write with this example. It can be a little complicated because we have been talking a lot about, okay, m, and m is from a size is of 35, so an array would be from 0 to 34, and that is still correct, but now we're adding this n, so it allows us to kind of skip this border around the edge. So we can skip all the I equals 0 and j equals 0 cases because it's acid. There's never going to be anything live in there, and also the ones on the upper end as well. You don't have to do that, but that was the starting point of what I wanted you to think about. Also, we have some constants just to define whether a cell is live or dead. If you chose to use 1 and 0, that's also perfectly fine. I think sometimes using 1 and 0 can lead to bugs because 0 is kind of our default, right? We have a 0 initialized array, and maybe that's not what we exactly wanted. This forces your code to be a bit more explicit in checking for live versus checking for dead. It's really not necessary. If you chose 1 and 0, true and false, your code should also work just the same. Finally, it looks quite ugly. This is the code that's using a console command sequence to print either a space, and that's all that's printing here. It looks uglier than it is. It is printing 2 spaces, and it's doing so with either a white background, which is what that command sequence does, or a black background. That's all that command's doing. We could talk about, and there's all sorts of different approaches. If you print 2 spaces back to back and you have this kind of console view, which is kind of stretched horizontally, or stretched vertically, excuse me, you get roughly a square. And that was the idea. That is one way, and there's many ways to kind of take a console and print a white or a black, roughly square thing. So you have your grid of size m by m, this 35 by 35. You're going to be ultimately printing 35 by 35, either white or black squares. That is kind of the starting point for that problem. I also defined the board itself, including the acid ring around it, of size n by n, and that gives us our array of size 37 by 37. And from there, I mean, you can look at the rest of the code, but this is just code that shows that like you can write a loop that does something. From there, I'd kind of back away from the code. If you get to that level of understanding and say, and instead of coding anymore, I'd want to kind of draw out what the whole concept is here in terms of the rules associated with the game of life. We can do that using Excel, because I certainly am not going to be able to do that using anything else. Okay, so it's this m by n array, board n of size n by n. And there's going to then be these, well, it's a two-dimensional array. There's going to be these rows, and there's going to be these columns. So we would generally want to think of, although it doesn't have to be this way, we generally want to think of our rows as being the I, that first dimension, and our columns being that j, the second dimension. This is going to be programming in Excel, but we'll get it working. And then we're going to have these indices, right, of starting at 0, that's part of our ring of acid, whatever you want to call it, all the way to, I'm not going to go all the way to 35 just for space considerations, all the way to, we'll say, 17 in this case. And likewise for our rows as well. So that is our I rows and our J columns. I don't think I don't know what the merge button would be. Okay, we can try this. That would be corresponding to all of our J rows or J columns. And all of our I rows. Let's put I here. Let's put board over here. Looks great. Doesn't matter. It's just to label what we have here. Text, vertical. Okay, looks great. So that's our start. That's going to start to define our grid and our array of all these cells that we have in the so-called game of life here. And for these indices, we are also then going to have to define, I got to be a little careful how I do this. So there's 0, and then that's 1, 1. Let me define it over 1 here. Let's move it over 1. So we have our 0 of rows and our 0 for our column. And it doesn't really matter if you have J versus I versus I versus J. And then for each of these, we would be then defining, let's just delete all the rows here. We would be then defining our individual elements. So this would be of 0, 0, all the way up through all the way up through 17, 17. I'm not going to label all of them. That would take forever, but we can center the text here so it looks a little bit better. You're just trying to get the outline grid right now? Yeah, we got it. We just got to do it for all these. So let's center all this, just to make it look a little bit better. And they should be, right? So for that entire row, so if this is our entire outer border here, let's just color code that for now. That would be, technically you'd want to maybe do like invalid or something, but we'll make it yellow. You can also define it as dead, right? It's an acid, and it is something that should never have a live cell in it. And then you have the remainder of the cells where we actually care about the values at any given time. And for most of them, I mean, it depends. If you look at what the code was doing to begin with, it just was randomly printing live versus printing dead. For better or for worse, and the Markdown README describes some examples, starting scenarios that make sense. Only certain starting patterns kind of lead to nice results. If you just arbitrarily set some live or randomly set live and dead cells, it'll do something, but it'll look kind of like garbage. It'll also be kind of hard to debug what is happening here. There are various patterns that kind of makes sense. But if, for example, we initialized everything as dead to begin with, including that wall of lava. Whereas we kind of separate out the wall from, let's see if we can actually get the color change here. The wall from the just dead by design. Make this at least a different color of font, if nothing else. They're all still dead, but some of them are only as initialized as dead. You would have to specify certain cells that you wouldn't actually be dead. You can play around with different patterns. There's a famous pattern that kind of looks like an R type shape, so you would specify those as being live. It'd be nice if I could make that look a little bit better, but for now, there's just a few in the middle making a little kind of R-type pattern that would lead to some interesting things based on the rules. And then otherwise, the other thing you have to take into account is that when you're looking at an individual cell in isolation, let me delete the color coding of some cells there. You really need to care about its neighbors. So if this cell is just an arbitrary ij location, we technically know where it is, but you're going to write a for loop, so it's going to be for an arbitrary ij location. What we care about are its neighbor cells, and we just really need to know what those indices would correspond to. And I think if you have that, the rest of the program is just really a matter of counting the rules and applying the rules and making sure you do that consistently. So if this is ij, what would the index of, well, let's do this cell. What would the index of this cell be? If the one in the center is ij, what would this one be? The ij minus 1. I think the nice thing about this is even if you get it wrong, if you're wrong consistently, I think you'll still get the right result. It's on the same row, so it's the same value of I. It is on one column to the left, so it's j minus 1. Likewise, now this one is what? Yeah, I think it's more common to call it j plus 1, but that's fine, it's correct. And then consequently, what's this one in the lower right-hand corner then? How about this one? Okay. This is a very common, I guess, design pattern with two-dimensional arrays, which is what are the dimensions of my nearest neighbors? And again, as long as you get all of the permutations, you'll be correct. But if you labeled it wrong, you'd still be correct because you're getting all those neighbors around it between I plus 1, j plus 1, and I minus 1, j minus 1, and all the other combinations. What's going on whenever you get to the very edge or at the corner between what do you do with your neighbor after that? And that's the reason we have the acid, because I think it's going to make your job as a programmer easier. It may not be as technically correct from the game of life simulation. So the question was, okay, yeah, when we're right here, no problem. But we're always worried about accessing our arrays outside of the bounds, right? Well, that is why that is why we have that vat of acid. If I take this pattern and instead do it, we'll just say, for instance, right here, it starts from the upper right-hand corner, then we're still okay. What has wound up happening is, yeah, we're technically out of range of the valid cells on the right-hand side. But if we initialize that acid to be dead and we never update those cells to be anything other than dead, code should still kind of work. So in terms of what your for loop is actually going to look like, even though you have these arrays of size 0 to 17, of valid indices 0 to 17, arrays of size 18, you're probably only going to want to have your for loops be 1 to 16. And you're going to only be updating cells in that 1 to 16. Going back what that means for our actual code and what the for loop should look like, Normally we do for I equals 0, I less than n, I plus plus. For this example, we should almost certainly do for I equals 1, I is less than or equal to m, I plus plus. And same for the j dimension as well. And if you do that, then not only are you worrying about, there's no issue with that out of bounds with I plus 1, j plus 1, or I minus 1, j minus 1, you're also going to get a logically correct result because it's going to treat those cells that are on the periphery as being dead. They're not going to contribute to a live count for any of those other cells. That's why I set up the problem that way. The alternative approach is to not do that, but then, for example, if the cells you were interested in were right here in one of the corners, you'd have to add a lot of if statements that check, oh, if I equals 0, then don't look at I minus 1. Or if j equals m, then don't look at j plus 1 because it's not a valid index. In this case, then, with the way we have it set up, every index is valid. You're not going to get any crashes. Just when you get to either I minus 1, I plus 1, j minus 1, j plus 1, you'll wind up on that border, and it'll be okay. So it'll give you a dead result, not an invalid access. Yep. Well, you have to then initialize 0 to 17 to be dead to begin with.
How do you make sure that doesn't get overridden by the for loop that you go from 1 to 16?
Yeah, your for loop would never update any of these border cells. They should always be dead no matter what. So they'll start dead, they stay dead, and they kind of were. The only other gotcha that I saw with some example programs here is, so we have this board variable defined. You're probably going to want to have like a next board also defined. Because the issue is, as we iterate from column to column and then row to row, and we're updating, and I should be more careful, and we're updating these values as we go, we still need to know the previous live or dead result to do the next set of calculations. So my suggestion is that when you write the code that checks, if it's live and there's 3 live neighbors or 4 live neighbors, then keep live, otherwise turn to dead. When you update that array, you should update next board so that we have the previous iteration, we're calculating the next iteration, and then only when you finish calculating that next iteration, then you go and copy next into current. You can do that with that same mem copy call we kind of played with, or you could write doubly nested for loops to just copy from next board of ij into board of ij. When we copied that array over, it'd be the same exact code here. And then you just print it. And that is another set of nested loops. If it's live, print live. If it's dead, print dead. Sometimes the other issue I saw is I wanted you to clear the screen, because otherwise it's just going to kind of scroll down and then it's going to look different on different computers. I want you to clear the screen. I want to print the board, and then I want to sleep for a little bit. Otherwise, it'll just update too quickly. You'll just be seeing flickering more than anything else. You have to make sure you do this in the right order. If you print the board, then clear the screen, then sleep, and that's kind of an easy mistake to make if you're just like adding those functions, then it'll technically be correct, but it'll print the board and then instantly clear it, and then sleep with the cleared board, and it'll look like the screen is blank. So there's reasons that even if your code is correct, you probably just want to follow this kind of basic structure in your code, kind of move those comments up and down depending on where you're adding your code, and then it should work generally well. Speaking of working generally well, let's end this disaster today. Thank you for your attempted help with mouse problems. Not uploading this, so hopefully everyone paid attention. Thank you.